if I have a liquid on a surface like water, that creates a drop due to the inward force. That's just a definition there in a surface tension. So I would look for that on my tests, because these next ones are all definitions. The shape of the liquid's meniscus. Now, I think I talked about this the first week of school when we learned how to read thermometers and volumetric flasks. There is a force that attracts it, adhesive force, and a cohesive force that attracts the material together. So the shape of the meniscus is determined by the magnitude of the cohesive forces in a liquid and the adhesive forces. I posted up a video where they talked about all these different properties and how they're formed. So yes, the force is all caused by hydrogen bonding, but the meniscus is caused by two things: a force of adhesion and cohesion. Okay, and again, that's a definition. This is a definition 20. Viscosity is your resistance to flow. Okay, and that's just a definition. All right, 21. I believe this is asking about capillary action. And if I put a small capillary tube inside water, the water will travel up the tube. And again, that's the same thing that causes your meniscus. It's the magnitude of the cohesive forces and the adhesive forces. The property responsible for the beating up of water is surface tension. Now, this is kind of like off the penny drop lab that I gave you. It's a property. Surface tension is a property. Surface tension is caused by hydrogen bonding. Hydrogen bonding is a force. So the answer to 22 is D. The substance with the largest heat of vaporization, okay, that's the one with the most force. All these are diatomic. They're all nonpolar. They're all LDF. If you look at your halogens on the periodic table, okay, that's what I'm looking at here. F, Cl, Br, and I. F is the least because it's the lightest, the least polarizable, the least electrons. Then more electrons, chlorine. Fluorine and chlorine are both gases. When you get to bromine, bromine has even more force and it becomes a liquid. And then the highest one is iodine. So iodine, because it has the most electrons and the most polarization, that's the most force, so iodine is found as a solid. Well, that makes your heat of vaporization, your delta H vape, the highest, because you have to put most heat in to overcome that attractive force. And then 24 is the last one I'm going to do here. Which of the following is an exothermic process? If I look at solid, liquid, gas, okay, the highest energy one is the gas, the lowest energy is the solid. So when I'm going up from lowest to highest, that's endothermic. So solid to liquid melting, endothermic. The delta H is positive. Okay, liquid to gas, that's boiling. Okay, you're absorbing energy, that's positive, that's endothermic. Okay, solid to gas would be something you don't really probably haven't seen so far, but you do see it when we get the phase diagrams. That's called sublimation. So subliming is also, all these have been going up, up, up. Now the exothermic processes are going to be condensation, going from a gas to a liquid, exothermic. Going from a gas right to a solid, that's deposition. And then going from a liquid to a solid, liquid to the solid would be freezing, and that's what we're looking at. I think I mentioned, well, I mentioned this in class. If you are a farmer and you had oranges, during a freeze they spray water over the oranges. The water becomes a solid, it freezes. Well, it releases the heat into the orange, and then the ice actually insulates your orange. All right, that's 1 to 24. Very good. I'll post this up.